Hello everyone. We are jumping straight into a side of AI that usually stays hidden behind the curtain: AI sustainability and the energy consumption of large models. In professional terms, this refers to the environmental footprint and power demands associated with the full life cycle of an AI system, particularly the massive electrical load required to train and run foundation models. In simple words, it's about realizing that every time your AI thinks, a power plant somewhere is working overtime. You've probably seen this at the office, where everyone is excited about a new chatbot, but nobody is looking at the utility bill. I like to think of it like this: if a standard Google search is like turning on a light bulb for a few seconds, generating one AI image is like fully charging your smartphone. Stay with me here, because as a governance professional, you can't just talk about smart tech, you have to talk about green tech. I once worked with a startup that was so focused on their model's accuracy that they didn't realize their cloud computing costs were doubling every month just because of the sheer electricity needed. This environmental cost is a major part of your risk profile. Understanding that AI is a power-hungry beast is our first step toward looking at the heaviest part of that consumption, which is the training phase. The biggest energy gulp happens during model training, which is the computationally intensive phase where an AI learns from massive datasets, often requiring thousands of specialized chips to run at full power for weeks or even months. To put this in simple terms, it's like a marathon runner who has to eat 10,000 calories a day just to get ready for the race. Let's break this down together. Training a single large language model can emit as much carbon as 5 cars over their entire lifetimes. I remember a data scientist who wanted to retrain a model every single night just to get a 0.1% increase in accuracy. I had to sit him down and explain that the cost of that tiny improvement was the same as keeping an entire office building lit for a year. We have to balance the brain power of the AI with the actual electrical power it consumes. But stay with me, because even after the training is done and the AI is smart, the energy consumption doesn't just stop. This leads us to the daily cost of keeping the AI awake, known as inference. Once a model is live, we deal with inference energy consumption, which is the power used every single time a user asks the AI a question or gives it a task. In simple words, this is the daily commute of the AI. While training is a big one-time event, inference happens millions of times a day. If you have 10,000 employees all using an AI assistant to summarize emails, those tiny sips of electricity turn into a giant ocean of power usage very quickly. You've probably seen how popular these tools are, but as a governor, you have to ask, is it worth the energy cost to use a giant power-hungry model just to write a 2-sentence RSVP? It's like using a massive semi-truck just to go buy a loaf of bread. Let's break this down. We need to be efficient with how we use the AI we've built. Now, if we want to lower these costs, we have to look at where these machines actually live, which brings us to data center efficiency. A huge part of sustainability is data center power usage effectiveness, PUE, a ratio that describes how efficiently a computer data center uses energy. Specifically, how much power is actually used by the AI chips versus how much is wasted on cooling and lights. In simple terms, it's like checking if your house has good insulation so you aren't wasting money on the air conditioner. Stay with me here. Not all clouds are created equal. Some data centers are powered by coal, while others use wind and solar. I once advised a company to move its AI workloads to a green region in a different country where the data center was cooled by naturally cold air and powered by hydroelectricity. Their carbon score dropped overnight without changing a single line of code. Choosing where your AI lives is one of the easiest ways to be a sustainable leader. But even in a greenhouse, we can still make the AI brain itself smaller and faster, which leads us to model optimization. To make AI more sustainable, we use model compression and distillation, which are technical tricks to shrink a giant AI model into a smaller, leaner version that does the same job using much less power. In simple words, it's like zipping a large file or turning a 500-page book into a 10-page summary that still tells the whole story. Let's break this down together. You don't always need a giant brain to do a simple task. I've seen teams take a massive model and prune away the parts it wasn't using, making it 50% faster and 50% cheaper to run. It's like cleaning out your closet. Once you get rid of the stuff you don't wear, you can find what you need much faster. This isn't just good for the planet, it's great for your company's budget. When we make the AI smaller and smarter, we are practicing true governance. This technical cleanup is the final piece of our sustainability puzzle. The final step in managing AI sustainability is environmental disclosure, where the organization publicly reports the carbon footprint and energy and water usage of its AI systems as part of its corporate responsibility. In simple words, it's posting your electric bill for everyone to see. As an AIGP, you might be the one responsible for gathering these numbers. Investors and customers are starting to ask, is your AI clean? I remember a company that won a massive contract not because their AI was the fastest, but because they could prove it was the most sustainable. Transparency builds trust. When you can show that you are monitoring, optimizing, and choosing green energy, you turn a potential scandal into a competitive advantage. You're proving that your company is ready for a future where energy is precious.